In this video, we continue with our discussion of Chapter 7 on atmospheric disturbances. And in this video, we're going to focus specifically on fronts. And you hear a lot about this if you watch the weather. You might hear the meteorologist say there's a cold front coming, there's a warm front coming. What exactly does that mean? Obviously, it tells you whether you can expect the temperature to be warmer or cooler. But what can you expect in terms of precipitation or lack thereof? First of all, what is a front? That's the boundary where two unlike air masses meet. When you look at a weather map, there are different ways the fronts are symbolized, and please be familiar with these for the midterm exam. For a warm front, I like to think of it as hot, because hot red. So a warm front will show up in red, and there'll be the half circles here. And a cold front will be like a biting cold. So those are the blue triangles. If they kind of remind you of teeth, you could think of biting cold, and that might help you remember what a cold front symbol looks like. For a stationary front, you have movement of neither the cold nor the warm front. So you have both symbols. The warm front would be attempting to move in this direction. The cold front would be attempting to move in the opposite direction. With an occluded front, most likely the cold front has overtaken the warm front, and now it's just one big frontal system. We'll start here with cold fronts. Cold fronts are going to be more, generally speaking, more violent than warm fronts. They'll be more stormy, but they're short, and you'll get a short burst of heavy precipitation along this front line here, where the cold air advances, and this area here that we kind of call the nose is where the warm air is forced to rise. And remember, we talked about in Chapter 6 with precipitation mechanisms, one of those mechanisms was frontal lifting. Particularly when you have a cold front coming in, you have cold, dense air, the air is heavy, and it will push the warm air up, warm air that's lighter and more buoyant. So you get instability here all along this line. In this case, we're seeing cumulonimbus clouds and thunder. Well, we're not seeing thunder, but we can assume there'll be thunder along with this lightning and heavy precipitation along the front line. So these cold fronts move pretty quickly. That dense air moves rapidly, and it's going to move faster than a warm front. So what we'll see with the mid-latitude cyclone when the cold front comes in is you have that precipitation along the cold front line, and then as the cold front continues to pass through, you get a decrease in temperature, a noticeable, significant decrease in temperature. So the rapid lifting of this warm air is what gives it the more violent nature and gives us more blustery weather. And I like this photo here because usually you can't see the edge or this nose here of the cold front, but in this particular case you can. So how about those warm fronts? Those are whereas a cold front shows the rapid, a steep incline for the rise of that warm air. In this case, if it's the warm front moving in, it's still going to be forced to rise, but it's going to do so much more gently than if a cold front was coming in. And the precipitation will be more protracted over a larger area, occurring more broadly, and you won't have the cumulonimbus clouds, the big thunderstorms, but instead you'll get more stratus types clouds, nimbostratus at the lower level, altostratus, mid-level, cirrostratus at the high level, or maybe cirrus clouds, as you would see over here. So both fronts can produce precipitation, but you'll want to remember that a cold front moves more quickly and causes more, generally speaking, more violent blustery weather than a warm front will. Other types of fronts, and we looked at the symbols already for a stationary front. Here you have neither air mass displacing the other, but you also might get an occluded front where the cold front here, before the point of occlusion, this would have looked kind of like a letter V, where the cold front was coming in, and then at this point in the cyclone, the cold front has overtaken the warm front, so you have the occluded front here, but you still have a cold front and a warm front before this cold front will eventually overtake the warm front most likely, and you'll get an occluded front when the front dissipates. So that's just a brief overview of fronts, and that will help you when we get to the mid-latitude cyclones, which I'll be discussing in the next video.